In this video, I'm talking about one of the biggest issues with the 3D touch bed leveling sensor and how to avoid it, and we're starting right now. Hello, my name is Daniel. Welcome to the Crosslink channel. I would like to help you being more successful with 3D printing, and if you're here for the first time, subscribe and hit the bell notification icon so you don't miss anything. If you've seen my video about the Edelkrone Flex Tilt Head 3D, I didn't mention in that video that it actually took me a few attempts to print those parts. So let's talk about what went wrong and why the 3D touch sensor was one of the biggest reasons. Also make sure that you stick around until the end of the video because I'm giving away an Ender 3 or Anet A8 3D printer by the end of July 2019. I started to print the parts for the Flex Tilt Head in blue PLA on the Anet A8. And I did not watch the print the whole time. I think after around 2 hours I went down to the basement and wanted to check the print and discovered that it had a severely shifted top layer. The 3D touch sensor's needle had fallen down. Also, it was bent to one side, so it was unable to retract and got stuck in the printed parts. So the question to me was, how did it happen? And I realized that the printhead at the same time was also rippling over the highest layer and creating vibrations. And because this specific print consists of multiple parts which are printed at the same time, the printhead sometimes has to travel across already printed parts when it continues printing the next part. And this can potentially cause vibrations off the printhead. As a result, the 3D touch needle had fallen out because the vibrations got too intense, obviously. What normally happens in this case is that the 3D touch immediately tries to retract the needle because it knows its internal state was retracted, but if it hits a printed part sideways in this very moment, it can bend and then it's stuck so it cannot retract anymore. In the end, I printed the parts for the Flex Tilt Head 3D on the Ender 3. And to be honest, this is a topic in general, how to get better reliability and consistent results. So I'm really planning to do a whole video series about not quality, but really reliability. So what you don't want is you coming back after a print of 10, 20 hours, and then you realize that the printer has been going for 10 hours just printing in the air and producing spaghetti. But let's keep going with the video. So let's talk about 3 things to do now. First, how to fix the bent needle of the 3D touch. Second, why and how to magnetize the 3D touch needle so it is less prone to falling out. And third, how to avoid the printhead rippling over already printed parts when it has to move around the printing area. So let's start with fixing the needle first. I am wrapping a little bit of tape around the needle because I will use a gripper to bend it back into a perpendicular position, and I don't want to scratch it because that might cause friction in the housing of the 3D touch sensor. Also, I moved the carriage up to a higher position so I can reach the needle better. So let's now bend the needle back, and I hope this is going to work out for you as it is for me. And now it's time to remove the tape, don't forget that. Okay, just make sure that you can easily push the needle back into the sensor housing and nothing is scratching when you pull it back out. So it should be moving quite freely. Now, if the printer is being switched on, the sensor normally does a self-test. That should work without any issues, otherwise you have to check if the needle is really straight. Now let's do the second step, which will also allow us to recheck if the needle is really straight. We are releasing the little grub screw on top of the sensor now. And now you're able to push the needle into the sensor completely to pull it out to the top. Now you can check if the needle is completely straight, and if not, try to make it straight finally. So the principle of this sensor is that the needle is moved up and down by an electromagnet, and when the electromagnet is turned off and is in the upper position, it by itself is magnetized and it will stick to the grub screw so it stays in that upper position. The issue is that the magnetization of the needle has been done in the factory, and due to vibrations and transportation it can lose some of that initial magnetization. You can magnetize the needle very simply with a magnetizing tool. This tool, by the way, is also really cool to magnetize your screwdrivers and your bits. I always do this with my screwdrivers if I know that I have to screw something in an area where it's very narrow and I can't reach the spot where the screw needs to go with my hands. If you want to get one, the link is in the description down below. So this step should at least improve the stickiness of the needle to the grub screw when it's in that upper position. Yeah, and that looks good. Finally, you should put the needle back into the housing and reinsert the grub screw. The desired position of the grub screw is when it's flush with the sensor's surface. Redoing the self-test shows me that everything looks fine. Okay, finally, we want to make sure that when printing multiple parts at the same time, we get less vibrations when the printhead moves to the next part. What we need to do is to enable a feature in the slicer software. In this case, it's Cura, and there it's called Z-hop when retracted. Z-hop when retracted. What this feature does is that every time when a retract is happening, and this happens when the printhead has to move to another place to continue printing, it will move the printer nozzle up a little bit, do the movement, and then go down by the same amount. The result will be at least a lower probability that your nozzle might scratch over printed parts and avoid vibrations that might otherwise cause this 3D touch needle to fall down. I realized we didn't do the comment reading for a while, so let's start right into it. These comments are from the video about the Flex Tilt Head 3D, and the first comment is from Cord Wolf. I like the idea of co-manufacturing. Looking forward to seeing more companies adopt this strategy. Thanks for sharing, Daniel. Yeah, I really had a point in making this video because I wanted to share this with you to show you there is companies out there to have fresh ideas how to use 3D printing in a manufacturing process and how to share sort of the manufacturing process with you. Then Gerald Ondan gave a comment. This was interesting. Thanks for making this. Yeah, Gerald, I'm also a big fan of your channel, so thanks for commenting on this video. So next comment is from Vegas Guy. Good informative video, interesting concept, but I suspect most 3D designers will prefer to use brass inserts for screw threads, machine screws and roller bearings, etc. for their creations. I agree. Well, the downside for this is these kind of metal parts are not giving you the same kind of permanent friction that the parts from Edelchrome give you. So I think they are especially designed to be tightened and then have and keep the same amount of friction all the time. I think that makes it a little bit special, and it's not that easy to replicate that with normal screws and nuts and these kind of parts. Happy Mad Scientist commented, nice, finally some reasonably priced camera gear. Absolutely agree. I think the original Flex Tilt Head is pretty expensive. I bought it, I think it's 149, and this one is 29, so if you count in printed parts, then you're way below 50. Then Dan W has a comment. Can you comment on actual usage? I purchased, printed and built this and found that it didn't move smoothly and that the joints needed to each be loosened and tightened before and after each move. If the unit was loose enough to move, it was too loose to hold the camera. It also squeaks when moving. I was hoping you'd actually show it in use and was rather disappointed when you just showed it already set up with no footage. Comment on how it performs versus the original. Well, let's look at it quickly because I have the original one here and I also have the 3D printed one. So if you look at the 3D printed one, I think you need to find the spot where it's just tightened enough to be still movable but still give you enough friction. I think to find that spot is probably one of the most difficult things. And what I can definitely agree, it squeaks a little bit, but that probably depends on the material that you use. You don't have to use PLA, you could also use PETG, and that is probably less prone to make noise. So if you compare this with the original one, which is made from metal, when you open it for the first time, you will recognize that it's really tightened, very strong. So it's really hard to move. You also can change the amount of friction on this and adjust it, but you will have sort of the same problem. You will have a spot where it's hard to move and a spot where it's too easy to move. Now let's have a look at the comments from my last video about the Anycubic Ultra Base review. The first comment is from Gary. Great video as always, thanks for that. Good review and good timing. I just received my Ultra Base. Mainly ordered mine due to the warping, probably with the original Anet heat bed. yeah, definitely check it out. I think the fact is it's a much thicker surface in the end, so you have the metal plate and then you have the glass plate that gives it a little bit more mass, and it's definitely going to distribute the heat better. And I'm curious for your results, so just post them in the comments section. Then Christoph has another comment. You haven't mentioned what material the plate works and doesn't work well with. So far I have tested PLA and PETG, and I'm trying out other materials soon, but I can say that for PLA and PETG it works pretty well. My experience is that with glue it works much better, but it definitely also works without glue. Percival has a final question on this video. Sadly, I ruined the ultra base glass with the nozzle. How can I solve this? Well, the thing is, as I said, it's really hard to remove the glass plate from the heat bed once it's glued to the heat bed. If it's not broken and it's just scratched, just go for it, just continue printing, maybe polish it with some sandpaper and clean it with alcohol. Scratches will come anyway over time, that's a fact. So that's it for the comments. Now let's come to the giveaway part. I'm giving away either an Ender 3 or an Anet A8 3D printer by the end of July 2019. It's not sponsored by anyone, it's just sponsored by me. If you win, you can decide which printer you want. To enter the giveaway, please leave a comment in the comment section down below why you want one of these printers and what are you planning to create with it. I will go through all the comments of this video and also all videos that I release until the end of July 2019, and I'm going to pick a winner. Leave your Twitter or Instagram alias so I can contact you directly, and I'm going to announce the winner in the first video in August 2019. If you think this video was helpful, like and subscribe, and if you really want to support me creating new content for you, then check out my Patreon page where you can support me with a small pledge every month. Thank you so much for watching. See you next time.